In this lesson, we will explore the concepts of voltage and power and how they relate to what we have learned before. We already learned that voltage is some kind of force that pushes electrons through a conductor. We use a simple analogy to try to understand how voltage works. We say that a difference in voltage is like a slanted table, and if we put a ball on top of it, the ball will slide to the lower end. The larger the difference in voltages, in this case, the heights, the more push will be for the electrons to flow. As in the tables, what really matters is the difference in voltage. These two tables can have different heights of legs, but if the difference is the same, the push will be the same. For that reason, when measuring voltage, we use two probes of a multimeter and we connect them to 2 points of the circuit. That will give us the voltage difference between those 2 points. There is another important convention. The ground symbol that we have seen in all the diagrams represents the main reference terminal. Ground corresponds to a point with 0 volts, and we can measure any voltage using it as reference. The ground symbol is very important in simulations. If you don't add a ground to the circuit, the simulation will fail or will even return strange results. Here we can see what's the equivalent of a volt. A volt is 1 joule per coulomb. We already know that coulombs are a measure of charge. Joules are a measure of work. For example, to lift my coffee mug, I require a certain amount of energy, which is measured in joules. So, 1 volt is the amount of work that needs to be done to push 1 coulomb of charge. For example, 100 volts is like having 100 joules of work for every coulomb of charge. Now let's talk about power. Let's say that I want to know how much work is necessary to keep an electric bulb turned on during a second. We can start from the definition of current, which is 1 coulomb per second. We know that a volt is 1 joule per coulomb. If we multiply volts by amperes, we can see in the equation that we have 1 coulomb divided by 1 coulomb, and they cancel each other. That leaves us with a unit that is joules per second, which is exactly what we are trying to calculate. 1 joule per second is a watt, and as we just saw, it is obtained by multiplying the voltage by the current. In the case of a light bulb, we can measure the voltage across its terminals and the current, and with that we obtain the number of watts it is using. The unit watt may sound familiar to you if you have a charger for your laptop or phone. They usually specify how many watts they provide. The one in my laptop is 30 watts, which means that it can provide 30 joules every second. One thing that you may have noticed is that when charging your phone, the phone or the charger can become hot. This is because when converting the energy, part of it is wasted and is converted to heat. Power converters try to be as efficient as possible, but even the best ones turn a small percentage of energy into heat. A simple model like this can be used to exemplify the dissipated energy. We have a voltage source connected to a resistor. We can calculate the current using Ohm's law. Once we have the current, we can calculate the power. Here we can experiment a bit with values of resistors and voltage source. If the voltage source is 10 volts and the resistor is 1 kilo ohm, the power is 0.1 watts. If we decrease the resistor value, the power will increase. Once we reach 400 ohms, we have 0.25 watts of dissipation. This can be already too much since the resistors that I usually use are rated for a maximum of 1/4 watt. One important thing that we need to be aware is the behavior of the dissipated power in terms of the current. If we take Ohm's law and we write the equation of the power in terms of the current and resistance, we can see that there is a nonlinear behavior. The power increases quadratically as the current increases. We can see in the simulation how drastic the increase of power is as the current increases. For that reason, electric systems that require large amount of energy are fed with a power supply that has a high voltage in order to reduce the current and decrease the losses. As a summary for this lesson, the base units of voltage are work over charge, or joules per coulomb. Measuring the voltage requires two probes, and one is used as reference. Power is the amount of work performed in a second. The power dissipation produces heat, and last, the power dissipation increases quadratically with the current.